This is Sarah with RegisteredNurseRN.com, and I'm going to talk to you about dimensional analysis. Dimensional analysis is used to solve drug and dosage calculation problems that you may encounter in nursing school. Before you start working dimensional analysis problems, you must first learn the metric table. In my previous video, I talked about the metric table and went over it with you. If you need a copy of the metric table, you can go to our website, registerednursern.com/metric table, and you can print it out. It's in Microsoft .x format, and you can have that as a reference. And behind me is a metric table, and I'm going to show you how to use the metric table and to solve conversion problems. But first, let me talk about dimensional analysis. Dimensional analysis is a problem-solving technique where you can solve for any numbers or values and multiply them by 1 and not change the value. So I'm going to show you, just using a basic problem, how you would set one up and how it works. Once you get the hang of it, solving drug and dosage calculations is really easy. Also, we are doing a video series of how to solve different types of drug and dosage calculations problems that you may encounter in nursing school. So be sure to check those out. We'll have them listed on our website and on this YouTube channel. So let's start working some problems. The first problem I have is 8 grams equals how many milligrams? This is just a basic conversion problem that you may be asked to solve. Above here we have the metric table. It's a very good idea you memorize this metric table before you start working the problems. That way you can just work the problem and not have to go back and look at the table. But since we're beginning, we need the table in front of us, and so we're going to learn how to do it by looking at the table. I've already worked the problem out here because I felt like having it worked out, you could see what I was talking about, and then I'll go back and work another problem by hand. Okay, how I like to set my problems up is I like to first set the problem up. You have the top and the bottom. These are not fractions. A lot of people think that these are fractions. It's not fractions, so get out of the mindset of thinking it's a fraction. I put 8 grams equals how many milligrams? Some people like to put 1, but I like to put how many milligrams. The key is you are trying to get from grams to milligrams because the problem is asking for milligrams. So what we're going to do is, in dimensional analysis, you work the problems diagonally like this, and you want to cancel out whatever is going here. Here is grams, so we wanted to cancel that out. So we put 8 grams equals how many milligrams? So we're going to write grams, and if we look at our metric table, we will see that 1 gram equals 1,000 milligrams. So we're going to put 1 gram equals 1,000 milligrams. And the problem was asking us for milligrams, so we're done. All we have to do now is multiply and divide. We're going to multiply 8 times 1,000, which equals 8,000. Multiply everything on the bottom. The only thing on the bottom is 1. So you'll put 8,000 divided by 1, which equals 8,000 milligrams. There's 8,000 milligrams and 8 grams. So that was a basic problem. Now let's take it a little step further. Okay, let's see. 8 grams equals how many micrograms? Before we were doing milligrams, but let's do micrograms. Again, I'm going to set up the problem like this. 8 grams equals how many micrograms? So we're going to move grams over here because remember you work dimensional analysis diagonally, so we're going to move our grams, and we're going to go up to our metric table, and we're going to see how many grams are in a microgram. So as you look at your metric table, you don't really see that 1 gram equals so many micrograms. So we're going to go to milligrams. You see, according to the table, 1 gram equals 1,000 milligrams. So we'll do that. Our goal is to get to micrograms. These dimensional analysis problems can be several steps. So 1 gram equals 1,000 milligrams. Okay, we have canceled out our grams, so we're going to mark our grams out. Now, write milligrams over here, because again, we work diagonally, and we're going to go up to our table, and we're trying to get to micrograms. So let's see if we can find on the table if something will equal to micrograms. We do. We see 1 milligram equals 1,000 micrograms. So we're going to write 1, and it equals 1,000 micrograms, and write 1,000 micrograms. And we're going to cancel out our milligrams. Okay, and what was the problem asking us for? It was asking us for micrograms. So we are done. We can multiply and divide now. So you're going to take 8 times 1,000 times 1,000, which equals 8 million. And you're going to multiply on the bottom. 1 times 1 equals 1. And then you're going to divide. 8 million divided by 1 equals 8 million. So there are 8 million micrograms in 8 grams. Okay, let's do one more problem just to make sure you get the hang of it. This problem is 100 milliliters equals how many ounces? Again, we're going to set up our problem with what it's asking for. 100 milliliters equals how many ounces? With dimensional analysis, again, we work diagonally, so we're going to move milliliters over here, and we're going to go and refer to our metric table. How can we get from milliliters to ounces? So we see up here, there's really not 1 milliliter equals so many ounces. So this is probably going to be a multiple step problem. So it says that 15 milliliters equals 1 tablespoon. And then 2 tablespoons equals 1 ounce. So what we'll do is we'll start out with milliliters. So we'll write 15 milliliters equals 1 tablespoon. Milliliters cancels out. And now we're going to move tablespoons down here at the bottom, and we're going to refer to our table. And our key is to get to ounces. So we see that 2 tablespoons equals 1 ounce. So we're going to put 2 tablespoons equals 1 ounce. And tablespoons cancels out. Now we're done because we've got to ounces is what we were supposed to solve for. So we are going to multiply everything at the top and bottom and then divide. 100 times 1 times 1 is 100. And 15 times 2 is 30. 100 divided by 30 is 3. So your answer is there are 3 ounces in 100 milliliters. So that is the basic conversions on how to use dimensional analysis. I hope that helped explain it. I remember whenever I was in nursing school, whenever I actually figured out how to use dimensional analysis, I thought it was the best thing ever. Please go to our website, registerednursern.com. We have a lot of practice quizzes that you can work and see how well you did on the quiz for free. It's registerednursern.com, and we have a slider on the page. Just click quizzes and it will take you there. Be sure to also check out our video tutorials because we're going to be solving more complex conversion problems that you'll see in nursing school, like IV boluses, dosage and calculations based on a patient's weight, and it gets a little bit more in depth. So I hope this helped clarify some things, and thank you so much for watching, and be sure to check out our website, registerednursern.com.